problem 9.1, we're looking for the payback period. What's the payback period for the following series of cash flows? We have a cash outflow today of $5,500, cash inflows of $1,300, $1,500, $1,900, and $1,400 respectively in the next 4 years. What's the payback period? The equation is payback period is time to have your cash inflows cover your cash outflows. How many years does it take till we pay back the CFO if we borrow $5,500 today from CFO? So we take it 1 year at a time. We take the first cash outflow, and then from that we take the $1,300. So there's $4,200 yet to cover after year one. Then we subtract the next cash flow of $1,500. That leaves us with $2,700. And we subtract the next cash flow of $1,900. That leaves us with $800 after 3 years, and then remaining that $800 as a percent of the last year, $1,400, is 0.571429 years. So the answer to problem number 1 is 3. So it took us 3 years, 1, 2, 3, 0.571429 years. That's your answer to problem number 1. In problem number 9.2, we have a project providing cash flows of $585 a year for 8 years. What's the payback period if the initial cost is $1,700, $3,300, and $4,900? So if you were to draw this out on a timeline, as I encourage for all problems in chapter 6 through 11, we'd see 585, 585, 585, 585. You see an 8-year annuity of $585. We could do it using the method in problem number 1 and subtract the 585 from the cash outflow each year, or we can simply divide the 1,700, the 3,300, and the 4,900 by 585, since it's the same consistent cash flow each year. So in this case, the payback period is just the cash outflow divided by the constant cash inflow of 585. So solution for the $1,700 case, I just take 1,700 over 585, and it takes me 2.90598 years, 2.9 years. $3,300 would take us 5.64 years to get our money back, and with $4,900 beyond the period, because they only give 585 for 8 years. If we assume we had another year of 585, it would take 8.38 years to pay us back. And the only reason we can, again, divide in this case is because the cash flows are all even and the same each and every year. If the cash flows were different, we'd have to use the method we used in problem number 1. There's your answer to problem number 2. In problem number 3, we have Bicoastal's CFO imposing a payback period of 3 years. Basically, CFO saying, don't come into my office with any project of yours that requires more than 3 years to pay back. Should the CFO accept either project? First project costing $60,000, second project costing $70,000. Payback period is time for the CFO to get his or her initial cash outflows back in. How long does it take for those cash inflows to cover the cash outflow? So in the first case, we have $60,000 out, and then you promise the CFO you're going to pay her back $23,000, $28,000, $21,000, and $8,000 respectively. In the second cash flow will be you're going in and asking for $70,000 for your project, and you're going to pay back $15,000, $18,000, $26,000, and $230,000 in the fourth year. So let's take a look at these two projects. If we look at cash flow A first, after the first year, we are about $37,000 short of paying her back, with 23 coming in. Then we bring in another 28. We have a remainder of $9,000, and then $9,000 over the $21,000 you're going to turn in year number 3 is a fraction of 0.42857. So you'll get that paid back in 2.42857 years, well under the 3 years. And so we would say accept, because this meets the deadline of 3 years. Cash flow B, we have $70,000 going out, and with that you're going to pay her back $15,000, $18,000, $26,000, and then $230,000. So after the first year, you still owe $55,000, 70 minus 15. Then you're going to turn in another 18. That leaves a remainder of $37,000, still owe. And then you're going to turn in 26. That leaves a remainder of $11,000. And then $11,000 over this $230,000 in the last year gives a remainder, a time period of 0.047826 years to pay back that 11,000 remainder. So we get an answer of 3.047826. So the pure answer would be no, reject, because we have a deadline of paying the CFO back of 3 years. However, in this case, we might use a little bit of common sense on this one and go back into the CFO's office and ask her if she could wait a short time, and you'll start paying some or all this back. This $11,000 back. How long would she have to wait? Well, what's 0.047826 years? It's about 17 and a half days. She'd have to wait till, I would think, some of these cash flows of 230,000 would start coming in. If they only come in on the last day, you'd have to ask her to be patient till the last day of the year, in which case she'd get a big bonus of $230,000 of cash. So it's a judgment decision on the CFO's part, where she might want to flex on her decision of this 3-year payback period. She might want to wait till the 4th year to get the benefits of this $230,000 if you ask. That's the answer to problem number 3. In problem number 4, we see this project has annual cash inflows of $3,200, $4,100, $5,300, and $4,500 and a discount rate of 14%. What's the payback period on this one if the initial cost is $5,900, $8,000, and $11,000? So we have 3 cases here. Cash outflows. The discounted payback is the time to recover the initial cost from the discounted cash inflows. So I take these cash inflows, $3,200, $4,100, $5,300, and $4,500, and discount them back to today at 14%. So I'll take $3,200 divided by 1.14, and I'll get 2,807.0175. Then I'll take $4,100 and try and find what it is discounted. I'm going to bring that back 2 years. I'm going to divide 4,100 by 1.14 squared and get 3,154.8169 in all 3 cases. Then the 5,300, I'm going to bring that back 3 years. 5,300 divided by 1.14 cubed is 3,577.3490 on a discounted basis. And finally 4,500, I'm going to bring that back 4 years and divide that by 1.14 to the 4th, and I get 2664.3612. So this table shows you the discounted cash inflows in each case. Now I have to ask the same question I asked in problem number 1. How long does it take me to pay the CFO back if I ask her for $5,900 today on a discounted basis? So in this one, of the $5,900, after year 1, I have a remainder of 3,092.98. After this discounted cash flow, and then I take 3,092.98 divided by 3,154.8169, and I get a remainder of 0.98 years. So the answer in the $5,900 case is 1.98 years. In the second case of 8,000, it's going to take a little bit longer to pay these back because I have the same discounted cash inflows. I have year 1, year 2, I use them up, and then I need part of year 3. The remainder is 2038.1656 is how much I have to take out of year 3, and that's about 0.5697 years. So the answer to the 8,000 case is 2.5697 years. And in the third case of 11,000 bucks, it's going to take a little bit longer. I have to proceed down this discounted cash inflow table a little bit further. And after 3 years, I still have a remainder of 1460.8166. So I've used up this one, and this one, and now I'm going to take 1460.8166 out of the 4th year. That's about half a year, 0.5483 years, and the answer is 3.5483 years. There are your answers to problem number 4. In problem 9.5, we have a series of cash flows of $2,900 a year for 6 years. The initial project cost is $10,000, and what is the discounted payback period? How many years will it take to pay back the $10,000 if the discount rate is 0%, 5%, and 19%? Obviously, it takes longer the higher the discount rate goes up. So at 0%, I just see $2,900, $2,900, $2,900 each year for 6 years. And then at 5%, I discount those 2,900s divided by 1.05, divided by 1.05 squared, 1.05 cubed, and so on. And then at 19%, I take 2,900 divided by 1.19, 1.19 squared, 1.19 cubed, 1.19 fourth, and so on to get this table. And then we just go down through the table and see when we get paid back. So in case 0%, it takes about 3 years plus, almost $3,000 a year because the $2,900 is not discounted at all. So it's $2,900, $2,900 the first year, $2,900 the second year, and $2,900 the third year. And then our remainder after 3 years is $1,300, and $1,300 out of that fourth year, $2,900 is 0.4483 years. So the discounted payback period in this 0% case is 3.4483 years. In the 5%, it's going to take a little bit longer. Here are your discounted payback values. Each year, the 2,900 again divided by 1.05, 1.05 squared, 1.05 cubed, and so on down the list. We take about 3 years in this case, plus we need about 88% of this fourth year. Our remainder after 3 years is 2,103 divided by 2,385 gives us 3.88128 years. 3.88 years to pay back at 5%, small discount rate. At this higher discount rate, you see these $2,900 values getting greatly discounted. So 2,900 divided by 1.19, divided by 1.19 squared, divided by 1.19 cubed, 1.19 fourth, and so on. All the way down, we find that 6 years we won't have enough. We're actually somewhat short. We're actually somewhat short if we go through the 6 years, so the answer will be never. But if I want to find out how long after 6 years it might be, I throw in a pretend cash flow number 7 of $2,900, discounted by 1.19 to the 7th, of which I get $858. And that $112 shortfall divided by the 858 gives me 0.13 years. So the answer in this case will be 6.13 years. It's a little bit more than 6 years. Again, you have to make the assumption that there would be that 7th year cash flow of $2,900. There are your answers to problem number 5. In problem number 6, we have a new manufacturing plant costing $12 million. Straight line depreciated to 0 over 4 years on the books. Projected net income is $1,854,300 in the first year, $1,907,600 in the second year, $1,876,000 in the third year, $1,329,500 in the fourth year. What is the AAR, average accounting return percent? Average accounting return is average net income over average book value. So it's a very simple equation. The average book value, I can bisect it because of straight line depreciation. So I can bisect the depreciation, which starts out at 12 million and over 4 years goes down to 0. Bisect the line by dividing by 2. So 12 million divided by 2 is $6 million of average book value. And the average net income is 1,854,300 plus 1,907,600 plus 1,876,000 plus 1,329,500. All that divided by 4 years, and I get average net income of 1741850. I take average net income over average book value to get the AAR. 1741850 divided by 6 million is 29.0308%. Then there's your answer to problem number 6. And problem number 9.7, the required return of this company is 14%. That's their hurdle rate. Should the firm accept the following project under the IRR decision rule? And the IRR decision rule is if this project's cash flows and required internal rate of return, IRR, jumps over the required rate of return or hurdle rate, then we accept. So we have to find the rate where the discounted cash inflows equal the cash outflow of $28,000. So we have $28,000 out, $12,000 in, $15,000 in, and $11,000 in. And what is the rate that makes these discounted cash inflows equal to that cash outflow? So right away, when I see the letters IRR, I write down on the paper NPV equals 0 equals minus the first cash outflow of $28,000 plus $12,000 over 1 plus R, $15,000 over 1 plus R squared, bringing it back 2 years, and then $11,000 divided by 1 plus R to the third. What is the rate that I plug into these three equations, portions of the equation, such that these cash inflows discounted equal to $28,000? I do trial and error. 1%, 2%, 3%, or 5%, 10%, 15%. You can do it in 5% jumps. And I find out that somewhere between 15 and 20%, 17.1827 is your rate at which your discounted cash inflows equals your cash outflow. We accept this project because if you're able to bring in these cash inflows, it gives you an internal rate of return of 17.1827%. Accept it because this project jumps over the hurdle rate or the required rate of return of 14%. And that's your answer to problem number 7. In problem 9.8, we have a firm using the NPV rule for problem number 7, cash flows, same cash flows as in problem 7. Should the firm accept this project at 11% discount rate, required rate of return, and or 25%? NPV is equal to minus the cash outflow plus the discounted cash inflow. So I'm going to discount these 3 cash inflows by these rates to see if we should accept the project under the NPV rule. Again, we accept if the NPV is positive and reject if NPV is negative. So here are your discounted cash flows. 28,000 obviously not discounted at all. The 12,000 in the first case I'm going to divide by 1.11, and then the 15,000 I'm going to divide by 1.11 squared, and the 11,000 I'm going to divide by 1.11 cubed, and I get those discounted cash inflows. Add these all together and I get a NPV of 3028.2525. In the 11% case, I accept. In the 25% case, again, the $28,000 is not discounted. The 12,000 is discounted by 1.25. The 15,000 divided by 1.25 squared is 9,600, and the 11,000 divided by 1.25 cubed is 5,632,000. Add these together with the 28,000, I get negative 3,168. So at 25%, the discounted cash inflows don't cover the cash outflow, and I get a negative 3,168. So I would reject the project at a 25% discount rate. This NPV profile I've created here tells me that my IRR falls somewhere between 11% and 25%. And we did calculate that in the last problem, and it falls at 17.1827%, and this table verifies that. There's your answer to problem number 8. In problem number 9, we see that this project provides cash flows of $17,300 a year for 9 years, costs $79,000 today. To go forward with this project, if the required return is 8%, is this a good project? How about if the required return or hurdle rate is 20%? So the net present value that we're looking for is negative cash outflow plus the discounted cash inflows at these 2 discount rates. Solution NPV is minus 79,000 plus 17.3 over 1.08 plus 17.3 over 1.08 squared, 17.3 over 1.08 all the way out to the 9th year. And or I can realize that 17.3 is an annuity, 17.3, 17.3, 17.3, and use the annuity present value formula. So minus 79,000 plus 17.3 times 1 minus 1 over 1 plus r to the t, all of that over r. 1 minus 1 over 1.08 to the 9th over 0.08, which will give me the same answer as stringing it out longhand. A little bit safer to do it using method 2. So at 8%, my NPV is $29,071.16 positive, so I accept at 8%. And at 20%, my NPV is negative $9,264.28, so negative we reject is a decision. And if I want to find the internal rate of return, which would split those two, I take minus 79,000, I should say NPV equals 0 equals minus 79,000 plus 17.3 over 1 plus r plus 17.3 over 1 plus r squared all the way out to 1 plus r to the 9th, and find out where the discounted cash inflows equals my cash outflow. And I get an internal rate of return of 16.2516%. And we know, we can kind of guess that by looking at this little NPV profile we've created. We know that it's somewhere between 8% and 20%. It's going to be closer to 20% because the 9264 is closer to 0 than the positive 29071. So there are your answers to problem number 9. In problem 9.10, we have the following series of cash flows. We want to know what is the IRR percent, or the required rate for this project, the internal rate of return for this project. Whenever I see the letters IRR, I write down NPV equals 0 equals minus the cash outflow plus discounted cash inflows. So at what rate does this happen? At what rate does my NPV equals 0? So I write down NPV equals 0 equals minus 16,400 is the cash outflow plus the first cash inflow over 1 plus some rate, plus the second cash inflow 8,400 over 1 plus some rate squared, plus the third cash inflow 6,900 over 1 plus some rate cubed. What is that rate? that makes these discounted cash inflows equal to the cash outflow. And that rate is, by trial and error, 17.4248%. If I plug in 0.1742 in each of these R's, I should get an answer very close to zero when I subtract out the 16,400. There's your answer to problem number 10. For problem 911, they want to know in problem 10, what's the NPV at 0%, discount rate 20%, 30%, 10%, 10, 20, and 30% discount rates. Here are your cash flows again, negative 16,400 out. And today, at time 0, year 1, 7,100, year 2, end of year 2, 8,400, and end of year 3, $6,900. Net present value is equal to minus cash outflow today, plus the discounted cash inflows. So what do I get at 0%? I would take 7,100 divided by 1 plus 70, 1 plus 0 to the first power, 8,400 divided by 1 plus 0 to the second power, and 6,900 divided by 1 plus 0 to the third power. So these are the same number, 7,100, 8,400, and 6,900. There's no discounting on these at 0%. So I'll have a negative 16,400 going out, positive 22,400 coming in. So my NPV at 0% is $6,000. There's no discounting. I just get these pure cash flows coming in as stated. 10%, I take 7,100 divided by 1.1. 8,400 divided by 1.1 squared, and 6,900 divided by 1.1 cubed. Add those up, and I get an NPV of 2180.77. At 20%, I'd be dividing these by 1.2, 1.2 squared, and 1.2 cubed. And I get a negative NPV at 20% of 656.94. And at 30%, I divide this by 1.3, I divide this one by 1.3 squared, and I divide that one by 1.3 cubed, and I get a negative NPV of negative 2827.40. So I would accept the project at 0 and 10% discount rates, and I would reject the project at 20 and 30% discount rates. And we can see once again in this NPV profile that my IRR comes in right there, obviously closer to 20%. And we calculated that in the prior problem. It's 17.4248%. There are your answers to problem number 11. In problem 9.12, Garage Inc. has two mutually exclusive projects. And we want to know what's the IRR. If the required return is 11%, what's the NPV? So we want the internal rate of return where the rate at which my NPV equals 0, where my discounted cash inflows equals my cash outflow, and then my NPV at 11%. Over what range of values do I accept project A or project B? So, equation, the rate, IRR is the rate at which my NPV equals 0, discounted cash inflows equal the cash outflow, the rate at which that happens. So what is that rate? And also NPV is minus cash outflow plus the discounted cash inflows. So here are your cash flows, 29,000 out in both projects. A will give you 14,400 in, 12,300 in, 9,200 in, and 5,100 in. And B gives you these inflows for that $29,000 investment. I also want to calculate, create a third column out here called B minus A, where I take the column B values minus the column A values, and then on these on the subtraction, I can operate and do an IRR, and I can calculate the crossover rate, because whenever I have mutually exclusive projects that cost the same amount of money, I can take A or B, I can't take both. These things may cross over when I do an NPV profile, and indeed that's what happens in this case. So to calculate the internal rate of return, I take minus NPV equals 0 equals minus 29,000 plus 14,400 over 1 plus some rate, plus 12,300 over 1 plus some rate squared, plus 9,200 over 1 plus some rate cubed, plus 5,100 over 1 plus some rate to the fourth. Solve for R, and I get a internal rate of return of 18.5553%. That's for project A. For project B, I do the same thing. Again, if I'm looking for the IRR, I write down NPV equals 0 equals minus 29,000 plus 4,300 over 1 plus some rate, plus 9,800 over 1 plus some rate squared, 15,200 over 1 plus some rate cubed, and 16,800 over 1 plus some rate to the fourth. Doing the math, solving for R, I get and IRR of 17.4152%. So in this case, I would take project A because it has a higher IRR, it jumps over the hurdle better. But again, these things might cross over, so I have to be careful and calculate the crossover rate in a minute. First, I'm going to calculate the NPV at 11%. To do that, I take minus 29,000 plus 14,4 over 1.11 plus 12,300 over 1.11 squared plus 9,200 over 1.11 third and 5,100 over 1 plus 0.11 to the fourth. I get an NPV at 11% of 4042.4176. Doing the same thing for project B, I get an NPV of $5,008.56. So in this case, I would take project B. It has the better NPV at 11%. Okay. Now I have to calculate the crossover rate. So I will do an IRR on this series of cash flows on column B minus A. I simply took B minus A, 29 minus 29 minus 29 equals 0. 4,300 minus 14,4 equals minus 10,100. Watch your sign. You can do B minus A or A minus B. Just be careful of your sign. 9,800 minus 12,300 equals negative 2,500. 15,200 minus 9,200 is $6,000. And 16,800 minus 5,100 is 11,700. Now I do an IRR on that column. NPV equals 0 plus or minus 10,100 over 1 plus R plus or minus 2,500 over 1 plus R squared plus a 6,000 over 1 plus R cubed plus 11,700 over 1 plus R the fourth. Solve for R and I get that crossover rate of 14.8313%. Indeed, these two NPV profiles do cross over. The curves cross over at 14.83%, and I would pick project B at rates lower than 14.83%, and I would pick project A at rates higher than 14.83%. So be careful whenever you have two mutually exclusive projects. Calculate the IRR, but be aware that these NPV profiles might cross over, and always do the NPV. NPV is the best decision rule. There are your answers to problem number 12. In problem 913, we have NPV profiles for X and Y. Here are some cash flows in X and Y. Show the NPV profile from 0% to 25%. So we're going to sketch that out. Discount rates, we're going to discount these cash flows for both projects from 0 to 25%. What's the crossover rate? Do these mutually exclusive projects cross over? They both cost $20,000. Project X will give you $8,850, $9,100, and $8,800 in return over the 3 years. Project Y will give you $10,100 in, $7,800 in year 2, and $8,700 in year 3. In case these things cross over, I want to do a Y minus X column also. So I'm going to take 20,000 minus 20,000 minus 20,000, get 0. 10,100 minus 8,850 and get 1,250. 7,800 minus 9,100 and get negative 1,300. Again, watch your sign. And 8,700 minus 8,800, I get negative 100. I'm going to use that possibly for a possible crossover rate. Calculate the crossover rate. So the crossover rate is the point where the NPV of Y minus X equals 0 equals, and the net present value of these cash flows is the minus the cash outflow plus the discounted cash inflows. So I've calculated these for you at 0%, 5%, 10%, 15, 20, and 25, and I could put these on an XY graph, and we would see that indeed these things do cross over. For rates below the crossover rate, I take project X. So at 0%, 6,750 is higher than NPV of Y of 6,600, I take X. For 5%, 4284 is higher than 4209, I take project X again at 5%. At 10%, 2177 is higher than 2164, I take X. Now a crossover happens. At 15%, I take Y because 400 is higher than 362. At 20% discount rate, negative 1131 is better than negative 1212. I take Y again. And at 25%, negative 2473 is better than negative 2590. I take Y again. So we see a crossover happen in here somewhere between 10 and 15%. I need to calculate that rate. So I take NPV equals 0 equals of the Y minus X column. So NPV equals 0 equals 0 plus 1250 over 1 plus some rate plus a minus 1300 over 1 plus some rate squared plus a minus 100 over 1 plus some rate cubed. And I get a crossover rate calculated of 11.194%. That's my crossover rate. So therefore, I take project X at rates below 11.1946, and I take project Y at rates above 11.1946%. There are your answers to problem number 13. In problem number 14, we have Lightsweep Petroleum trying to evaluate a large generation project with following cash flows. Today we need to put out $39 million to get this project going. For that, we'll get $63 million in year number 1, and then we have to give out $12 million in year number 2, perhaps to do a cleanup or that sort of a thing. We have a 12% required return in this company. So compute the IRR, compute the NPV at 12%. What is the IRR? The rate at which my discounted cash inflows equals my cash outflow, or the rate at which NPV equals 0. So first I'm going to do the NPV, which is the best method, and then I'll show you how to do the IRR and let you do it yourself. NPV is negative 39 million plus 63 million over 1.12 plus a negative 12 million over 1.12 squared. This will give me the net present value, and we get an NPV of 7,683,673.47. And in this case, this is a positive NPV except the project at 12% required rate of return. This might be troubling to the CFO. CFO likes to see out-year cash flows coming in versus this outflow of 12 million bucks, so that might be a little troubling at first glance. The question is, what is the IRR on this set of non-conventional cash flows? We have minus, plus, minus. Descartes' rule of sign tells us that there might be multiple cash flows. The maximum number of, or multiple IRRs, because of these differing cash flows. We have minus, plus, minus in the cash flow situation. We might have multiple IRRs. Descartes' rule of sign says there may be as many as 2 in this case, because the sign changes twice. There might be 2, there might be 1, there might be no IRRs. So how would I calculate the internal rate of return? Whenever I see the letters IRR, I write down NPV equals 0 equals minus the first cash outflow plus the first cash inflow over 1 plus some rate plus the next cash inflow over 1 plus some rate squared, and so on. So question for you is, what is the IRR and how many of them are there? I'm going to let you work that one out yourself. There might be 2, there might be 1, there might be none. In problem 915, what's profitability index for this series of cash flows at discount rates of 10%, 15%, and 22%? So here are your cash flows times 0, cash outflow of 18,000, year 1, end of year 1, cash inflow of 10,300, end of year 2, 9,200 in, and end of year 3, 5,700 in. And the formula or equation for profitability index is discounted cash inflows divided by today's cash outflow. And this is your benefit to cost ratio compared to what you learned in econ typically is cost benefit. This is benefit to cost. So the PI at 10% is 10,300 divided by 1.1 plus 9,200 over 1.1 squared plus 5,700 over 1.1 cubed. All that divided by the cost or cash outflow today of 18,000. I get a PI of 1.1805, and that is a positive NPV because it's greater than 1. PI at 15% is 10,300 over 1.15 plus 9,200 over 1.15 squared plus 5,700 over 1.15 cubed. I get a PI of 1.0923, which again is greater than 1, so I have a positive NPV in this case. And then at 22%, I take 10,300 over 1.22 plus 9,200 over 1.22 squared plus 5,700 over 1.22 cubed. Divide all of that by 18,000 cash outflow, and I get a 0.9868, which is less than 1. So the PI less than 1 means a negative NPV. I would accept these two at 10 and 15%, and I'd reject the project at 22%. Notice a strong correlation between in decision making between the PI and the NPV decision rule. Greater than 1 PI means positive NPV, less than 1 PI means negative NPV. There's your answers to problem number 15.